This is lesson 1 on chapter 5, and today we are going to start this chapter. And we will try to answer this essential question at the end of this chapter, which is how can you use numbers and symbols to represent mathematical ideas? Okay, and in this lesson, we are going to be talking about algebraic expressions. Okay, we will be defining algebraic expressions, a variable. Okay, what is algebra, a coefficient, and when we say define a variable. So those are the things that we are going to be doing in this lesson. Okay, so let's take a look at the definition of a variable and take note of it. So a variable is a symbol that represents an unknown quantity. Okay, so a variable is usually represented by a letter. Okay, so it is a symbol which is represented by a letter that represents an unknown quantity. An algebraic expression on the such as n plus 2, it is an expression that contains variables, numbers, and at least one operation. Okay, again, it is an expression first and foremost, and it contains variables, numbers, and at least one operation. So if you notice in n plus 2, n is your variable, at least one operation is the addition sign, number is uh, 2 right there. Okay, so let's take a look at this Venn diagram and let's see how we can fill this in. So write each of the following phrases in the correct section of the Venn diagram. Contains an operation, has variables and numbers, has only numbers. Now, if you are familiar with Venn diagram, when you talk about these two circles intersect, meaning this part of the Venn diagram will have the characteristic of algebraic expression and numerical expression. Okay? This part of the Venn diagram where the circles don't intersect will only be for numerical expression. This part of the Venn diagram will only be for algebraic expression. Okay? So let's take a look at this one. Has only numbers. So when you talk about a numerical expression, okay, it will only have numbers. So we'll put it here, has only numbers. Okay? In an algebraic expression on the other hand, so we're done with this one. An algebraic expression has variables and numbers right here. So has variables, okay, and numbers. And finally contains an operation. Both of them contains an operation. So contains an operation. Okay. One good example of a numerical expression is, let's say, has only numbers. Say 3. Okay, that's a numerical expression. But you might ask, okay, Mr. Rancis, if 3 is a numerical expression, where is the operation there? Because it says it contains an operation. Well, we can actually write 3 as 3 times 1. Okay? Now you can see that there's an operation which is multiplication. So in these types of numerical expressions, it has an operation because you're multiplying it by 1. So on the example has variables and numbers, n plus 2 is one of them. Okay, x uh, plus 6 is another numerical expression because you have your variable there. Sorry, it's an algebraic expression because you have your variable there, contains an operation, and contains a number. Okay, another good example, well, another example that you will see is y. So why is y again an algebraic expression, you might ask? Again, when you talk about an algebraic expression, it has to contain an operation and it has to have a number, okay, and variables. So in the variable y, okay, variable y is actually equal to 1 times y. The identity property of multiplication, very similar to numerical expression. Using the identity property of multiplication, 1 times y will fulfill the definition of an algebraic expression. It will contain an operation, which is multiplication. It will contain a number, which is the number 1, and your variable. The only reason why we don't use the number 1 here is because y is given to be 1 times 1, 1 times y, or simply y, using the identity property of multiplication. Okay, so let's move on. Let's take a look at the real world link and let's see. The expression f minus 32 in parentheses times 5 over 9 can be used to convert a temperature from Fahrenheit to Celsius. In this algebraic expression, the variable f represents the temperature in degrees Fahrenheit. Okay, so if you want to convert from Celsius to Fahrenheit, okay, you can use this formula to be able to find the temperature in Celsius. So F represents the temperature in Fahrenheit. Okay, all right, let's move on. Let us take a look at how to evaluate an algebraic expression. Okay, so let's take a look at some definitions for now. So the branch of mathematics that involves expressions with variables is called algebra. In algebra, the multiplication sign is often omitted. Omitted means that it is removed. You don't see it anymore. Okay, so when you have variables which involves expressions, you are basically talking about algebra in math. Okay, so expressions with variables is called algebra. Okay, or what we call the math of symbols. Okay, and again, multiplication is not shown. The multiplication sign is omitted or not shown. Let's take a look at some examples of that. So if you look at this one, for example, 6d, okay, means 6 times d right here. So that means 6 times d. So that is 6d. Okay, 9st means 9 times s times d. So 9st means 9 times s times d. Okay. Moving it forward, mn means m times n. And finally, a cubed, okay, simply means a times a times a. Okay. So those are what these expressions mean. Okay. And if you notice, you don't see the multiplication sign anymore. Okay. So another term that we need to understand is the word coefficient. Okay. So as a coefficient, the numerical factor, okay, of, of a multiplication expression that contains a variable is called the coefficient. So 6 is the coefficient of 6d. Why is that? Because 6 is the numerical factor and you have a variable next to d. So the coefficient of 6d is 6. Okay? And this one right here, the coefficient of 9st is 9 because you have these variables and this is the numerical factor or the factor that is a number. Okay? Now, if you ask, okay, Mr. Francis, what is the coefficient of mn? Again, from the example from what we talked about in expressions, numerical expressions and algebraic expressions, there is an invisible 1, okay, before mn because of the identity property of multiplication. So the coefficient of mn is actually 1. Same thing with a cube. The coefficient of a cube is also 1. Okay? but you don't write 1 anymore because of the identity property of multiplication. Whatever you multiply with 1 will always be the same number, and that's the reason why you are just writing mn and a cubed. Okay? So again, moving on with coefficients, okay, expressions like y over 2 can be written as y divided by 2 or y times 1/2. Okay? So that means in y over 2, we can also say that the coefficient of y over 2 is 1/2. Okay? So this one can be written as 1/2 times y. So 1/2 is the coefficient of this particular expression. Okay? All right, another term that we need to go back on and define is what we call evaluate. The word evaluate means find the value of. Okay? Find the value of, which means there are two things we need to do here. First thing we need to do is substitute. And the second thing we need to do when we evaluate is simplify. So first we substitute and then we simplify it for us to be able to find the value of. Okay? So here in example number 1, it's asking us to evaluate 2 times the quantity n plus 3 if the value of n is equal to 4. So we want to find the value of this expression if n is equal to -4. Okay? Now again, the first thing we need to do here is we need to substitute, meaning we need to substitute the value of -4 to n. We are going to plug -4 to n right there. Okay, and this is the next step. So now after plugging it in, you can see that n is now represented by -4. So this becomes 2 times the quantity -4 plus 3. Okay, and from what you learned in your order of operations, okay, order of operations tells us that please excuse my dear Aunt Sally, meaning we do parentheses first. Okay, this is parentheses, exponents, multiplication or division, addition or subtraction. So this is the uh, sequence of operations that we need to do, or the sequence of uh, events that need to happen first for us to be able to find the value of a particular expression. So we need to solve what's in the parentheses, okay, and then deal with exponents, and then we deal with multiplication or division, and then after that, that's only when we try to solve addition or subtraction. So in this case, we have 2 times the quantity -4 plus 3. If you notice, -4 plus 3 is in parentheses, and that's the reason why we are solving that first. -4 plus 3 is -1. So now we have solved -4 plus 3, which gives us -1. We now go to multiplication or division. So we simply multiply 2 times -1 will give us -2. So when we evaluate 2 times n plus 3, okay, where n is equal to -4, the value of n is equal to -2. Okay, let's take a look at example number 2 and see how this works. Again, we want to evaluate 8w minus 2v if the value of w is 5 and v is equal to -3. Okay, so first things first, we need to substitute. Okay, so we get the value of 5 right there and plug it into w right there. So you notice that w is equal to 5 and v is equal to 3. And we are getting it from this. W equals 5, v equals 3. Okay, that's the first thing we do. Again, using our order of operations, we know that we need to multiply 8 times 5 first and 2 times 3 before we can subtract. So 4 times 5 is 40. 2 times 3 is 6. So when we do that, this is what we get, 14 minus 6. So now we can use subtraction to simplify this. So now we're simply on the simplifying phase of evaluate. The simplified form of 40 minus 6 is 34. So when we evaluate 8w minus 2v, okay, where w equals 5 and v equals 3, it will be equal to 34. Okay? Okay, let's take a look at the third example. Evaluate 4y cubed plus 2y if y equals to 3. Okay? So again, we first substitute, which is the first step in finding the value of this expression. So we substitute the value of y to 3. So that's your y. We substitute it to 3. And remember our order of operations. And please excuse my dear Aunt Sally, okay, where we can see that we need to do exponents first before we do multiplication or division. So we need to do 3 cubed first. 3 cubed means 3 times 3 times 3. Okay, 3 times 3 times 3, okay, is 27. So that's the reason why we have 27 here, because 3 times 3 times 3 will give us that. Okay, now we're done with exponents. Now we're going to multiply 4 times 27 first before we add 2. So we know that 4 times 27 is 110. 4 times 27 first, multiply that, and we add 2 will give us 110. Okay, so the value of 4y cubed plus 2, if y is equal to 3, is 110. Okay, do the got it problems, and let's see if you understand the 3 examples. Let's take a look at example number 4. And in example number 4, you have a formula, and let's read through it. Athletic trainers use the formula 3 times the quantity 220 minus A close quantity over 5, where A is the person's age, to find the minimum training heart rate. Find Latrina's minimum training heart rate if she is 15 years old. So if you go to the gym and ask to be trained, okay, first they will find your vital statistics, or vitals, as they call it. So for them to be able to find your minimum training heart rate, which is a heart rate that they need to work on so that they don't overwork you and they know what your capacity is, okay, they use this formula where A is a person's age, okay, and in this case now, when Latrina is 15 years old, we can use the formula, okay, again, this is the formula, 3 times the quantity 220 minus A all over 5, and the value of A is 15, okay, right there, since Latrina is 15 years old. So we substitute, we subtract 220 minus 15 first, okay, according to our order of operations, okay, and we get 3 times 205 over 5. Again, this is also considered a grouping symbol, just like parentheses, so we need to multiply first before we can divide by 5. So we multiply 3 times 205 will give us 615 over 5. Now we can divide. 615 over 5 is 123. So Latrina's minimum heart rate is 123 beats per minute. Okay? So do the got it problem and see if you understand example number 4. Okay? Let's take a look at example number 5. Marissa wants to buy a DVD player that costs $150. Okay, she already saved $25 and plans to save an additional $10 each week. Write an expression that represents the total amount of money Marissa has saved after any number of weeks. Okay, so this talks about writing expressions. And before we even go to example number 5, let's talk about how we can define a variable. So for us to be able to translate that, we need to understand this. So to translate a verbal phrase into an algebraic expression, the first step is to define the variable. So what does it mean to define a variable? When you define a variable, you choose a variable to represent an unknown quantity. Okay? So that's what defining a variable means. Okay? We choose a variable to represent an unknown quantity. And usually this is in letters. So when we define the variable, we choose a letter for us to represent an unknown quantity. So going back to Marissa, what do we know? She wants to buy a DVD that costs $150. She already saved 25 bucks and plans to save an additional $10 per week. Okay, write an expression that represents the total amount of money Marissa saved after the number of weeks. So, what are we trying to find here? Okay, we want to find, okay, according to the problem, okay, the total amount of Marissa, okay, saved after a number of weeks. So in words, okay, she has a savings of $25 plus $10 per week. So we know we need to define a variable, and we can define it as W, which represents the number of weeks. Okay, why is the number of weeks? Because here we do not know the number of weeks. She already saved 25 bucks for $10 each week. Okay, for us to be able to find the total amount of money, we need to know the number of weeks. Okay, so W represents the number of weeks. Okay, and if we are going to use that variable, we are going to be writing down 25, which is the money she already has, plus the $10, okay, times the number of weeks. So this is our expression 25 plus 10 times W, or simply put, remember algebra, you don't show the multiplication sign anymore. So this is how the expression looks like. 25 plus 10W represents a total saved after any number of weeks. Okay? So with this, let's take a look at example number 6, and let's see how this works. So refer to example number 5. Will Marissa have saved enough money to buy 100 DVD player, buy the $150 DVD player in 11 weeks? Use the expression 25 plus 10W. So we already have 25 plus 10W. Remember, 25 is the amount of money she saved, and she's planning to save $10 per week. So it's asking, does she have enough money in 11 weeks? So all we need to do here is we need to substitute. Okay, first write down the expression, and we know W represents 11 weeks. So we substitute W with 11. So 25 plus 10W will become 25 plus 10 times 11, which will give us, okay, 25 plus 110, which is 10 times 11. Okay, so we do multiplication first. And then after that, we add 25 plus 110 will give us 135. So Marissa will have saved $135 in 11 weeks. Since $135 is less than 150, Marissa will not have enough money to buy the DVD player. Okay? So do the got it problem, and let's see if you understand examples 5 and 6. And that's the end of our lesson. Thanks for watching.